previous class we have come across the word called as what is primal and what is dual, and why the duality concept is very important. We discussed about the 2 points why the duality concept is important. Fine. So the next topic is formulation of dual problem. So when we got the primal problem, we need to find or formulate the dual problem. So how to formulate the dual problem? So for formulating the dual problem, first we bring the given primal problem into canonical form. Fine. So I mean to say it is almost identical, that you can say it as a standard form or you can say it as a canonical form. Fine. So in further topics we are going to discuss about what is canonical form. Fine. At present we think it as canonical form is nothing but a standard form. Fine. That is how the standard form, maybe introduction of flat surface variables or artificial variables, is nothing but a standard form. Fine. But it is somewhat different compared to the standard form and the canonical form. But in later topics we will find how to generate a canonical form of the given LPP. Fine. If the LPP is not in canonical form. Fine. So but at presently we think it as canonical form is nothing but a standard form. So what we bring? We bring the LPP in the canonical form. In the canonical form. And the following changes. And the following changes are used in formulating the dual problem. And what happens here? So the following changes are to be used while formulating the dual. So the first one is change the objective function. Change the objective function of maximization. In the what? Primal. In the primal into minimization. One in the dual and vice versa. So the meaning of this step 1 is like, if primal has max objective function, what? Objective function is of maximization. Dual has to be min objective function. That is vice versa. If primal has objective function to be minimized, dual has to be an objective function, has to be maximized. That is what? Vice versa. This is 1 to 1. Whereas for Second one, the number of variables the number of variables in the primal will be the number of constraints in the dual, and vice versa. What happens here? The number of variables in the primal, that is primal objective function, I mean to say primal LPP, will be the number of constraints. Means what? The number of variables which are there in the primal LPP will become constraints in the dual LPP. And so if I suppose to say in Kannada, it is like this. Primal LPP ಇರುವಂತ ವೇರಿಯೇಬಲ್ಸ್ ಬಂದ್ಬಿಟ್ಟು ಕನ್ಸ್ಟೆಂಟ್ ಆಗ್ತಾವೆ ಇಲ್ಲಿ ಡ್ಯುಯಲ್ದಲ್ಲಿ. And there is a third point, the cost coefficients. The cost coefficients like C1, C2, C3 up to Cn in the objective function, in the objective function of the primal, will be in RHS, that is right hand side of the constraints in the dual, and vice versa. What happens here? The cost coefficients C1, C2, C3, I mean to say Cj, in the objective function of the primal will be in the right hand side of the constraints, and the right hand side of the constraints will become and what? Cost coefficients will become cost coefficients of primal. That is what? Vice versa. It is like the cost coefficients will become a right hand side of the constraints in a dual, whereas the right hand side of the dual variables or constraints will become what? Cost coefficients of objective function. Right? Then the fourth one, in forming the constraints in forming the constraints for the dual, we consider the transpose of the body matrix of the primal problem. What happens here? In forming the constraints for the dual, we consider what? Transpose of the body matrix of the primal problem. So what happens here? The primal problems, body matrix, we will find the transpose. So the transpose of that is nothing but the constraints of the dual. Fine.